here I am going to talk about Z-scores. Z-score measures how far away a data value is from mean in terms of the number of standard deviations. So the formula for Z-score is x minus mean over the standard deviation. So let's look at this example. Data value has a Z-score of 2 means the data value is 2 standard deviations above mean. A data value has a Z-score of -3 means the data value is 3 standard deviations below mean. Now let's look at this chart here. So this one on here means 1 standard deviation above mean and the Z-score is 1. So this 2 over here means 2 standard deviation above mean and the Z-score is 2. And then this over here means 3 standard deviation above mean and the Z-score is 3. Similarly, on the other side, this -1 over here means 1 standard deviation below mean and the Z-score is -1. This -2 on here means 2 standard deviation below mean and the Z-score is -2. And then this -3 on here means 3 standard deviation below mean and the Z-score is -3. So now let's look at some examples. Suppose mean height of trees on campus is 100 feet and standard deviation is 5 feet. You pick a tree with height 90 feet. How many standard deviation away is the height of this tree from this mean? So to answer this, we simply need to find the Z-score. We use the formula equals to x minus mean over standard deviation. So, but what are our x, our mean, and our standard deviation? So that is all given in this question. So mu is the given mean, which is this. And sigma is the given standard deviation, which is this. And x is the value for which we need to find Z-score. So on here, on this example, this is our x. So now, so simply our mean is 100, our standard deviation is 5, and our x is 90. So then simply all we need to do is plug in our numbers in this formula. So on plugging in the number, we get our x is 90, that's what we have here, and our mean is 100, and our standard deviation or sigma is 5. So on doing this math, we get 2 for the -2 for the Z-score. So this means the height of this tree is 2 standard deviations below the mean. Now let's look at another example. Suppose mean height of trees on a campus is 100 feet and standard deviation is 5 feet. You pick a tree with height 105 feet. So we need to find here how many standard deviations away is the height of this tree from the mean. So to answer this, we simply need to find the Z-score. We use the formula Z equals to x minus mean over sigma. So our x and mean and our sigma are given on the question. So mean is the given mean, sigma is the given standard deviation, and x is the value for which we need to find the Z-score. So here our mu is 100, our sigma is 5, and our x is 105. So we got these numbers from here. Then we just need to put these numbers into our formula, which is here. So our x is 105, our mu is 100, and our sigma is 5. So that's what we have here. So when we do this math, we get 1. Okay. So this means the height of this tree is 1 standard deviations above the mean. So let's look at another example here. Suppose mean height of trees on campus is 100 feet and the standard deviation is 5 feet. You pick a tree with height 107 feet. How many standard deviations away is the height of this tree from this mean? So basically, to answer this question, we simply need to find the z-score. We use the formula z equals to x minus mu over sigma. But what are our x, mean, and the standard deviation? So mu is the given mean, sigma is the given standard deviation, and x is the value for which we need to find z-score. So here, our mu is 100, our sigma is 5, our x is 107. Then we simply need to plug in these values in our formula. Okay, formula down here. So we know our x is 107, our mean is 100, and our standard deviation is 5. So when we do this math, we get 1.4. So this means the height of the tree is 1.4 standard deviations above the mean. Let's look at some more example for z-scores. Suppose mean equals to 100 and standard deviation equals to 7. Find the z-scores for the following values. So we need to find the z-scores for the following values whose mean is 100 and whose standard deviation is 7. So let's try to find the z-score when x equals to 110. So we know the formula for z is x minus mu over sigma. So on here, we know our x is 110 and our mu is 100, which is from here, and the standard deviation is 7. So on doing this math, we get 10 over 7, which is equal to 1.43. So let's look at another example. So we need to find z-score when our x is 100. So now we have this formula. We simply need to plug in the values into our formula. So we know our x is 100 and our mean is 100 and our standard deviation is 7. So on doing this, we get 0 over 7, which is also equal to 0. Now let's find z-score when x equals to 85. So we have this formula. And let's plug in these values in this formula. Okay, so our x is 85, our mean is 100, and our standard deviation is 7. So when we do this math, we get negative 15 over 7, so which is equal to negative 2.14. Let's find z-score when x equals to 98. We have this formula, z equals to x minus mean over sigma over standard deviation. So when we plug in these values into our formula, we get 98 minus 100 over 7. When we do this math, we get negative 2 over 7, which is equal to negative 0.29. Let's find the z-score when x is 150. So we know the formula of z is x minus mean over standard deviation. So let's simply plug in the numbers into this formula. So since our x is 150, our mean is 100, and our standard deviation is 7. So that's what we have here. We just plugged in the numbers into the formula. On doing this math, we get 50 over 7. So when we divide 50 by 7, we get 7.14. Now again, let's find the z-score for when x equals to 102. We have a formula of z, which is x minus mean over standard deviation. We know our x is 102 and our mean is 100 and the standard deviation is 7. So when we do this math, we get 2 over 7, and when we divide 2 by 7, we get 0.29. Again, let's find z-score when x equals to 93. Let's just put these values in this formula. So our x is 93, our mean is 100, and our standard deviation is 7. So when we do this math, we get negative 7 over 7, so that gives us negative 1. Let's find z-score when x equals to 107. Let's plug in the values into this formula. So we get 107 minus 100 over 7. So which is equal to 7 over 7, that is equal to 1. So here we need to find out which of these are extreme values. So we want to find out the extreme values, but note that the values with z-scores below negative 2 and above 2. So below negative 2 and above 2 are unusual or significant or extreme. Okay. So now we have to go back and look at these values. Okay. Looking at the z-scores, these values, we know the extreme values are 85 and 150. So this one, 85 and 150. So these two are the extreme values. We know that the values with the z-scores below negative 2 and above 2 are unusual or significant or extreme. So that's why in this case, 85 and 150 are extreme values because their z-scores are negative 2.14 and 7.14 respectively.